All right, today's topic is absolute value functions. So we're still talking about functions. We're talking about basically kind of the same thing we talked about in another video, where it's talking about moving functions around the graph and transforming them around the graph. But in this time, instead of being linear functions, absolute value functions. So first thing I want to show you is you're going to see a table, and it wants you to graph the function from a table. So it's going to give you a table full of numbers, right? And you're going to see x, and then you're going to see f of x, okay? Now what this feeds the f of x, right? Really what this is you can just say, f of x kind of just equals y, if you want to think of it that way when you're graphing it, okay? So that's going to give you something like this, where it's going to be -3, -2, -1, 0, and 1, and then on this side it'll be 0, -1, -2, -1, 0, right? And really, so it's going to give you this, and it wants you to graph it, okay? So that's really all, it's pretty easy, right? So it's going to give you, you're going to see a graph, all right? All right, and then you're just going to need to graph it, how it goes on here. All right, so the first point is -3 and 0, right? So -3 is your x, 0, remember, is basically your y. So -3 on the x, remember this is x, this is y. So 1, 2, 3, and then 0, so it stays here, follow the point. Next one, -2 and -1, so -2, so 1, 2, -1 going down 1. Next one's -1, -2, so -1, 1, 2, -2. Third one is 0, so it stays here, and then -1. And the last one is 1, 0, so you can kind of see, and you connect the dots, right? So you kind of see we have a V. We have a V here, okay? And that's really all there is to it. So I remember absolute value function, when you see it on a graph, is going to look like some sort of V shape where it has an angle in it, okay? I'll do one more example because it's really kind of self-explanatory. All right, so let's do one. Let's do 1, 2, 3, 4, and 5. And then let's make this one 0, -1, -2, -1. Okay. So now if we graph this, right, same type of deal. All right, so same deal, right? So first point, 1, 1. So we go right 1, and then up 1, so here. 2, 0, so 1, 2, and then it stays on the graph. 3, -1, so 1, 2, 3, and then down 1. 4, -2, 1, 2, 3, 4, down 2, 1, 2, and 5, -1. You can see how this is going here. Right here, 5, and -1. And then you kind of, once again, connect your dots there, right? So you kind of see how that graph is looking there. So that's really all there is to it for this part of the lesson. Now the other part is transformations, right? So this is the same thing, the same rules that we did in another video. We'll talk about transformations of linear functions. It's the same rules, okay? So I'm going to go through this fairly quickly, but I'll just show you some examples of what I'm talking about. So when we first talk about, we'll talk about translations again, okay? So translations, you're going to see something like this. You're going to see f of x equals x, absolute value of x, plus k, right? So when you see this, it's the same thing as what we did earlier with our movements, right? So if k is greater than 0, your function goes up, function goes up, all right? And if k is less than 0, function goes down. Right, so same type of deal, right? So you're going to see something like this. You see f of x equals absolute value of x plus 3, right? So in this case, your function will go, we'll shift up, right? And then if you see something like this, f of x equals x minus 4, right? It shifts down, right? So that's kind of how this. So it's the same rules that what we did last time, right? If it's outside of your absolute value, right, it's the k. That's the up and down one, right? So it's if it's more than 0, if it's positive number is more than 0, it goes up. If it's negative, it goes less than 0, it goes down, all right? All right, so then we can go left to right, right? F of x equals x minus h, and this is an absolute value. So instead of it being parentheses like it was in linear functions, absolute value functions, they're the absolute value lines, but it works the same way, right? So if h is greater than 0, it shifts right. And if h is less than 0, it shifts left. Right. So once again, this is the minus in the middle, right? So if you have something like this, we have x. If you have x plus 3, right, and it's like that, then it's this number. Remember, if it's minus, right. So if you see this, we're going to go. This is going to shift left. Left. This is going to shift left 3, right? And then if we see something like this, right, f of x equals x minus 5, right, this is going to shift right, okay? Because remember, it's a minus sign, right? So the minus is always there. So when you look at it, our 5 is a positive 5. It's greater than 0, so it goes right. This is the plus because this would be a negative 3. It cancels up the negative there, right? So that's kind of what we're looking at. So if you see the plus in the middle, it goes left. Minus in the middle, it goes right, okay? Now if we talk about dilations, right, same type of deal. Now we have f of x equals a absolute value of x, okay? So if a is greater than 1, all right, it's a vertical one. It's a vertical stretch, right? And if a is less than 1, it's a vertical compression, right? So now if we have this, we have f of x equals 3x like that. Then we know this is going to be a vertical. This a is bigger than 1, so it's going to be a vertical stretch. And if f of x is this, we have 2/5 x, right? This is less than 1. It's a fraction is less than 1, so it's going to be a vertical compression. All right. So remember, number outside the parentheses, right? It's going to be vertical, and then if it's bigger than 1, it's a stretch. If it's smaller than 1, a fraction, it's compression. I'll leave that up there. Now if we have this, where everything is in parentheses, right? Now we're talking about horizontal compressions and shifts, stretches, right? So now if it's in parentheses, right? If a is greater than 1, we have a horizontal compression, and if it's less than 1, we have a horizontal stretch. Right, so if we have this, x equals 4x, right? This is greater than 1. Greater than 1, so we have a horizontal compression. Like I said, I'm kind of going through this fast because we did this it's the same as a linear functions. And then same thing here, we have this where we have a fraction, let's say 1/3 x, and they're both in the absolute value lines, and we have a horizontal, and we have a stretch here. Right. So everything in parentheses, or sorry, everything in the absolute value lines, talking about horizontal, and if it's greater than 1, it's compression, if less than 1, it's stretch. So it's kind of the opposite of the vertical. If vertical was greater than 1, it's a stretch, right? But with horizontal, it's a compression. Okay. All right, we'll do one more. We'll do reflections. Okay. All right, so reflections, you have your function negative a x in the absolute value, right? So this is different because it has this negative in front, right? So now if your x is the only one in the absolute value lines, then it flips, right, across the x-axis, okay? So, and then same rules as before. So if we have this negative 3x, right, this is a vertical, because it's in the x is only in the lines here, so it's a vertical, right? Our number here outside is bigger than excuse me, is bigger than 1, so we have a stretch, and because it's negative out front, right, it flips x-axis, right? And then if we have this where it's less than 1, right, so less than 1, so same, it would be only the x in there. It's vertical, it's less than 1, so it's compression, and then it flips x-axis. Okay. Now, just like that, if we have this where everything is in the bars here, right? Now we have, instead of the x-axis, it's across the y-axis, right? So now everything in the bars, we flip across the y-axis, right? So make sure you write this separately. So now if we have this negative, let's say 6x, everything in everything in the absolute value bars there. Including the negative sign. If we have this, right, we have because it's in everything in, it's horizontal, all right, and because it's greater than 1, it's a compression, and then it's going to flip across the y-axis, okay, and then we have this negative and less than, right, it's a decimal but still less than 1, right? So it's still everything in, so it's horizontal, right? It's because it's horizontal and it's less than 1, we have a stretch, and this is going to flip because it's negative here, flip on the y-axis. Okay, so that's absolute value functions. The transformations, the same, like I said, same rules as if you're doing the linear functions transformations. That is just with, so the parentheses, you're going to have the absolute value bars here.